Who knows the difference of an integral component and a derivative component in a PID loop in controls? Well, don't worry about that. We're not going to talk about that today. We're going to talk about electronic building controls and kind of give you a who, what, when, where, how, why overview and how it applies to net zero buildings. My name's Tom Zaban. I'm the Executive Vice President, Sales and Marketing for Reliable Controls. It's a homegrown company here in Victoria, which started like 2 people in 1986, and now we're over 140 people out in our main building over at Hollowell Road, Craig Flower, and Admirals. Let's talk about building controls. So who is building controls and who benefits from building controls? So that's an important question. Well, just about everybody benefits from building controls. Anyone who works or lives in a building can certainly benefit from building controls, right? And that pretty well covers all of us. We all basically live and work in buildings unless we live out on the plains. So what are electronic building controls? Well, these are electronic building controls. Basically, they're small embedded microcontrollers that sit very much behind the scenes. You don't normally see them in buildings, and they're basically freely programmable devices, and that's very, very important. And here's a number of examples from a number of manufacturers around the world. They all kind of look like that. And I think one of these things looks not like the others. Can you guess which one? Yeah, I think that one. Small plug for us. So where are building controls? Where do we use them? And we use them basically in every kind of building. So these products are found all over: agriculture, transportation, education, healthcare. All kinds of facilities around the world use building controls. Our company focuses largely on commercial applications, although there are a number of larger residential type applications that use these products. For example, Dockside Green here in Victoria is one. So when do we have controls? When did they emerge? So a real quick sort of history in this. Many of you may not know that this is an industry that started in 1883 with good old Warren Johnson. And he realized that he could invent something that could detect falling temperatures and illuminate a light bulb in the boiler room, which then indicated to the janitors that it's time to shovel more of that great greenhouse gas burning coal into the burner to keep the building warm. And that was the very first thermostat that was designed back in 1883. So as time goes on, all throughout the remainder of the 1800s and right up until the 1980s, actually, much of the controls industry was using compressed air for controls. Pneumatic systems were very, very common. And these types of actuators and sensors were commonplace throughout that very long period of time. And a good number of existing commercial facilities still use pneumatic systems, but they all are gradually being renovated out. So the dawn of the digital age came in the 1980s, where we now had computer systems and electronics to start to make solid-state equipment. And I think most of us have seen this type of equipment in our commercial spaces. This is the programmable thermostat, and there's a gazillion of them out there. What's missing in this technology that's quite different than today is its ability to discuss and communicate and share information over the internet. So around 1995, there was quite a paradigm shift in the world of controls, where the internet now came to us. And we had these kinds of dinosaurs, which you rarely see anymore, the Hayes-compatible modem and the US robotics modems that would basically give us dial-up connection to an internet service provider, which was a new word in our lexicon back then. And we were able to communicate information from remote users, and we were able to communicate from buildings to buildings. Nowadays, the technology has evolved considerably. And, we use, things like our mobile phones to to go and access buildings, and we expect to be connected to Wi-Fi and share information this way. And we expect a very intuitive graphical interface to share information about how our buildings are performing. And this is the state of the art right now. We work over the cloud, and we work over our mobile phones. So how is this done? Building controls really have just a few simple concepts to them, and we'll just kind of go through them now so you can appreciate how controls work. First of all, we need to sense and control the physical world. So in building controls, we have all kinds of different sensors, measuring temperatures, measuring pressures, measuring refrigerant systems, measuring flow rates. And the upper right device here is a power meter, which will give us kilowatt hours, demand, phase-to-phase voltages, amperages, faults. This little red guy here is a current transducer that's installed on the wire power to your residence or your building, and it will measure the power through that. This is a duct probe which sits in the sheet metal of a duct, measuring the return temperature, mixed air temperature, or discharge air temperature. This is a relay. Little tiny relays like this can switch 240 volts AC, 10, 15 amps. The technology is very miniaturized, works extremely well, and there's tons and thousands of those. This is a pressure differential meter for water or for air, whatever you like. So we have a variety of sensors and relays that measure the physical world and control the physical world. And basically, if you have these sensors and devices, then you can wire them up to things like this, which is the controllers that we looked at. So lots of wiring that comes through, and we wire them to the inputs and the outputs. And yeah, it's not a very pretty looking situation, but this is typical of what you see. And then it's behind a metal enclosure, probably in a boiler room or a chiller room or an electrical room in a facility. So you don't really see it, but that's what you need to do. That's the work that's being done. And then once that's finished, we now network these multiple controllers. Sometimes there's hundreds, sometimes there's thousands of them in a facility. Sometimes there's just one. And we connect these controllers to themselves over various different networks, and then to buildings, to buildings, to buildings. And over the last 30 years, the entire industry has moved to adopt what we call an open protocol. As one of the previous speakers mentioned, ASHRAE, the American Society of Heating, Refrigeration, and Air Conditioning Engineers, they were presented with an issue 30 years ago that, hey, I just spent X number of hundreds of thousands of dollars to bring building controls into my 20-story office building, and now 3 years later you're telling me it's obsolete and I have to change it out. I'm not happy. So the American Society of Heating, Refrigeration, and Air Conditioning Engineers took on that challenge, and basically their solution was, well, in the world today, we really need to interoperate. Just a fancy word that means to share information. So we interoperate. How do we do that? We do that by adopting a common protocol, which in our industry is called the BACnet protocol. And the BACnet protocol is a short form for the Building Automation Control Network Protocol. And so this became an ANSI standard in 1995 and is now largely adopted worldwide. There are other protocols like Modbus, MBus, CBus, all kinds of other bus-type technologies which interoperate. But none of them, in our opinion anyway, is interoperable as this one, because it covers everything from HVAC to lighting to security to elevators, fire, life safety. It's designed to be extensive across all different areas of application. So once you network up all your buildings, you can now share information between buildings, and you can share that information on your mobile devices. Of course, after the sensors, controllers, and wiring is done and networking is done, one must program the technology. So this type of technology, as I mentioned, is freely programmable. At least the products we make are freely programmable, which is really nice, particularly when you get into complex buildings, which many green buildings and high performance buildings are, there's all kinds of different sequence of operations you want to do. For example, you might want to take a high performance CO2 heat pump and not only heat your hot water, but you might want to use the cooling side to refrigerate something. Or maybe you want to take the excessive heat that you're taking and put it into your hot tub. You know, all of these things, there's no off-the-shelf kind of device you can just pull from Canadian Tire and say, here you go, that's going to work. So the sequence of operations needs to be freely programmable, and that's what we do with these types of softwares. You have to program a database in the product. You have to program the graphics and user interface for the product. You get to program alarms and notifications, which go out to emails and come onto your smartphone with the product. And you need to, of course, program the sequence of operation, which has to be freely programmable. So there's a fair amount of programming that has to be done in order to make all of this work. Once you finish that programming, you now want to collect data. And these types of controllers inherently collect data. The products we make all collect data. Every one of them collect data on board. And you want that data because you want to verify performance of how your building's being controlled, how the temperatures are being controlled, how the water flow rates are being controlled, what battery charge you have in your solar array. You can monitor and measure and control all of these things. And in this particular bar chart that's being shown, this is actually the bar chart in our head office. And if you look at that, you'll say, well, what's the biggest consumer? My goodness, it's the plug load. Well, what happens when you get into very, very efficient buildings like net zero buildings? Now remember, net zero buildings doesn't mean it doesn't use energy. Yes, of course, net zero buildings use energy. Of course they do. But they just happen to generate as much energy as they use, so they net out. The difference between what they consume and what they produce is relatively small. So when you get into these very efficient buildings, which most net zero buildings would be, they have to be efficient, the mechanical system, the heating system actually becomes much smaller than you might think, and unregulated loads such as plug loads become your real challenge, how to manage that. So here in this particular commercial building, the plug loads are dominant, followed by lighting, which is still, even though this building has an enormous amount of LED lighting, lighting still is a significant consumer in buildings. And then we come to the main mechanical equipment, in this case an air source heat pump, and then so on down with other water pumps and fans that are in the building. So it's an interesting transition when you get into high performance buildings that the plug load can be your big challenge to overcome. Now once your data is all aggregated and analyzed, you can then prepare reports like this. And the products that we manufacture, of course there's a lot of software involved, you produce these energy reports, which are really, really helpful. I receive a report like this every week in the buildings that I manage. And it immediately tells me, you know, how the building's producing, its comfort in the space, where my electrical energy is going, where my gas energy is being used, and how I'm comparing that over a 3-year period for the month of January, month of February, month of March. So that's 2005, 2006, 2007. And you can see we had a pretty lousy winter this year. So and by the way, this is a passively ventilated facility you're looking at. So it was a dreadful year in our building this winter because it was so cold. But right now in April and May we'll pick up, and you can see how this particular building really goes below in the spring, summer, and fall months. You can produce reports which show your daily profile for electrical demands, and there's your gas consumption there, and you can do all kinds of pie charts, bar charts, all kinds of reporting. And the idea here is to send information to the occupants and to the facility managers so that they can take action and improve on the performance of their facilities. So this is the big question that we should be answering here. Why? Why do we need these things? Why do we need these controls? Well, kind of taking the macro look, In our country, in Canada, we produce about 750 megatons worth of greenhouse gases each year. So that's that guy there. And then these are all the provinces: Alberta, Ontario, Quebec, Saskatchewan, and there we are, a little old BC, of equivalent CO2 emissions per annum, which is about 65 megatons a year. Our province has committed to reduce greenhouse gases to below 33% the emissions that were generated in 2007, and we're going to meet that goal. That's our challenge by the year 2020. So there's 2020 right there, and there we are there. So by golly, I hope we can do that. I think we got our work cut out for us, folks. But this is why we're here. We need to reduce greenhouse gases. In an extension of this, our province has committed to reduce greenhouse gases by 80% by the year 2050, and this is our long-term goal. So we have an interim goal of 2020 to get down below 33% by the year 2020, and then an 80% reduction target below 2007, probably long after we're all expired. So this is very important for us. Where do our greenhouse gases come from in this province? The number one sector that generates greenhouse gases in the province of British Columbia is this guy, and that's the transportation sector. So cars, trucks, everything that we do to get to work, largely burning fossil fuels for transportation, is where most of our greenhouse gases are emitted. Number two is the built environment. Buildings. Number two, and that's where I'm at. I want to reduce our greenhouse gases, and I think that's what a lot of people here are at. How can we reduce our emissions generated from buildings? Well, net zero buildings are certainly going to help. If we look at the pie chart for British Columbia, actually this is the CRD now. So we're bringing it one step closer to home. Our home, CRD, 13 municipalities and 2 unregulated areas. Where do all of our greenhouse gases come from the CRD? Well, no surprise, transportation, number one. Very glad to see the electric vehicle community represented at this sustainability showcase, because that's what we need to do to help this. Mass transit too. I'm not here to talk about transportation, but it is the number one that you can do. Taking the bus will help. Only 11% of the people in the CRD take a bus. Heck, 10% of the people walk. This is where we're focused on, the built environment. 36% of our greenhouse gas emissions in the CRD come from the built environment. And it's roughly equal between residential and commercial. So that's our challenge. We need to reduce this. If we're going to meet this 2020 goal, status quo is there. We generate about 1.5 megatons of greenhouse gases each year in the CRD, compared to the 65 that the province produces. We need to reduce our targets by 33%. That means we've got to take out 500,000 tons of CO2 emissions in order to meet this target. And if we're going to have a hope of meeting that goal, I think building controls are going to be very, very important to do that. Because building controls, when installed and commissioned properly in an energy efficient building, will reduce the energy consumption in the proportion of greenhouse gases by about 30%. That's the track average. What we have here is a report from the Canada Green Building Council, our representative that manages and regulates the leadership in energy and environmental design for Canada, otherwise known as LEED. I hope some of you have heard of that. LEED is basically a scorecard program that identifies, monitors, tracks, and promotes energy-efficient buildings in Canada. There are 5,000 commercial facilities right now registered in Canada, and if you add the residential ones, it bumps it up by about another 1,200 to 6,200 total registered facilities under the LEED program in Canada. In British Columbia, 80 are certified, 90 at the silver level, 231 at the gold level, and 32 at the platinum level, the highest level right there. And I'm very happy to say out of those 32, a full 13 of those platinum LEED high efficiency buildings use reliable controls products. That's something very nice to have. So at the heart of every green building, you're going to need a sophisticated control system. So as a rule of thumb, and to really look at it in an easy way to compare buildings to buildings to buildings, this is a chart that Thomas Hartman produced, and Mr. Hartman is a very well-known advocate and engineer in the world, actually, for promoting energy efficiency in commercial buildings. And if we follow the ASHRAE guideline 90.1, if you follow this guideline in your commercial building, you will net out an efficiency use of 110 kilowatt hours per meter squared in your facility. And that is what we call the Energy Utilization Index. And so this is a very nice, easy way to compare buildings to buildings to buildings, because you just need to know how much energy do they consume in a year and divide it by the gross floor area, and bingo, bango, bongo. Most of the world's inventory is right in here. You want to be classified as a green building, you need to be in here. The head office building that we designed, which hosts 127 people right now, is right in here, which would be considered an advanced green building. So when you want to talk to people about, well, okay, I've just designed this building, well, what's your EUI? And if the architect can't answer that question, then I don't think he knows what he's talking about. Right? It's really important to understand these simple rules of thumbs, gross rules of thumbs, of what is an energy efficient building. And if there's anything you take away from this talk, I'd like you to just be aware that if I'm going to be a green building, I need to be 110 kilowatt hours per meter squared per annum or less. Right? And now you're talking about making an impact that's going to help us meet our goals here in the CRD. Right? Sure, we have goals in the province, we've got goals across the country, and we've got the Paris Agreement for worldwide 2 degrees Celsius capping. But, what are we going to do? What are we going to do here in Victoria? What are we going to do here in the CRD? And for me, I'm passionate about that. I think we've got to really start stepping up to this. Just a few more slides. Here's a net zero building that's almost complete right now. It's the Wyandotte Lodge in Columbus, Ohio. This is an education facility that's coming right along. They're about halfway commissioning it, and you can see all the PV array up on the top, and they'll be using geothermal in there as well. Nice little facility that our authorized dealers are doing. And, projects don't always have to be small. This is a large facility that we are currently doing. It's the Denver Water Operations Campus. So this is a large facility with multiple buildings. Here's the webcam shot from yesterday under construction. It's a 34-acre site. And they're planning to be LEED Gold, LEED Platinum, and they're wanting to be net zero as well. So I'm very, very excited for these folks, and we'll be tracking this to see how it all goes. These will be the first 2 net zero buildings that our company's been involved in, and I think they're pretty good candidates of the scale of what net zero can be done.